Well, hello, we are back with another video. I think what we might do is we might try and solve everything from here down. So let's get it going. Given a pointer to the head of a linked list in a specific position, determine the data value at that position. Count backwards from the tail node. The tail is at position 0. What do you mean? Its parent is 1. So does it tell me how many? Alright, well it's doing some shady crap because it's not gonna tell me how many items are in the list, because if it would tell me that, then I could just do a little switcheroo and be able to count forward, but now it's gonna force me to count all the way to the end. So I'm gonna have to count all the way to the end no matter what, but is there any way for me to make this more efficient? Position from tail. I'm given that at least. What I can do is I can keep track of the last two numbers, or well, if I had three position from, if I was supposed to take the third item from the tail, then I could say, let me keep track of the last two numbers as long as the next index or the next node is not empty, and I can just cycle through until I get to the end, and I should have access to that. Alright, so let me just go ahead and write this on paper, make sure I'm seeing this correctly. So, well, I had a proposed solution in my mind, but I think in order to really execute on it, I would need to keep an array that is position from tail long, and memory is a little more efficient in this scenario, but it's still, well, like memory is like more efficient in compute, but still, this is a weird thing that they're doing here. How do they really want me to go about doing this? Yeah, so there's two different ways I could go with this. I could either keep an array of position from tail, array of or of position from tail length, or I could recursively iterate through each element and then try to tell that element how far it is from the end of the list. Let me just ask ChatGPT really quick. It's not the most efficient or recommended solution. Alright, so there's a better approach than either of the things I've considered so far. Count backwards from the tail node. So they say it's a linked list, and it seems that it's a one-directional linked list. Backwards from the tail node. Because to do this in an O of n solution, which I think that it's possible, you can only iterate through the input once, and so that means that you would have to somehow have the memory address of the node found already before you even knew the endpoint. But I don't see a way of knowing what node you should be keeping.
Able to sneak a couple.
Oh, I knew it. Literally just said it too right there. I think I'm gonna just start coding. How do you reference? So I don't work with tuples often enough, so this will be a learning lesson for me. Are indexed, okay. He's falling down above. If pointer 2 minus pointer 1 is less than position from tail, pointer 2 dot next Well, I just passed this and I didn't realize I wasn't recording. I've just been sitting here talking to myself. So, what happened? Well, what happened was the very first thing they did was they threw an edge case at me. They said that the position from the end was 0. I don't know whenever you would really need a program that can do that, because I feel like it's a lot simpler to just say, well, go get the last element, but whatever. But they threw an edge case at me that was really screwing with like everything that I was doing here. So I basically just went up here and I solved their little BS edge case. And then I went and did the normal things. You have to go a 2-pointer approach because otherwise you would either have to use recursion or you would have to keep an array of the last position from tail elements. And neither of those really sound great, so we do this instead. And this little condition right here, well, first of all, we basically always increment pointer 2. Like, it's always going to get pushed forward. There's never a point where it won't. But the other thing we want to do is we want to conditionally say push pointer 2 or push pointer 1, depending on if it is at the right position. And how do you know if it's at the right position? It will be less than, well, it'll follow this condition. So that's over with. What did I struggle with? I think they hit me with an edge case. It was kind of annoying. I think I actually struggled a little bit to see a solution that was efficient to this, but I was like thinking O of n. Let me ask ChatGPT what the optimal time complexity is. Bro, 2-pointers are technically O of n? Oh, I see what they're doing. I was doing the same thing, just in a reformatted way. Like in a different way. Wow, so it is O of n. But I'm kind of struggling to understand how we can iterate through all of the input and then some, and it still be O of n complexity. I could see like a n of n plus m complexity. Alright, I'm going to pause this while I do a little research. Alright, well, it seems that I just had a slow moment. The reason this ends up being O of n instead of O of something else is because this program will at most ever iterate over the input twice. And most of the time it's going to be less than that, but regardless, you get like basically some constant times n, and you never consider constants. So, alright, we're good with the pointer to the head of a sorted list where the data and the nodes are in ascending order. Delete nodes and return a sorted list with each distinct value. Return a sorted list with each distinct value in the original list. What do you mean? Oh, I see. Alright, so we need while, first of all,
Quiet.
Alright, so we're going to iterate until current node.next is well, we're going to iterate until it's none. We're going to say if the next node has a value that is different from our own. So for example, if we start at, let's just look at the array here. If we start at 1, our start node is going to be this one, and the next node for that is going to be 2. Our value is going to be 1. We're going to start by looking at the next node, and in this case their values are different, and so we're going to say start node dot next is equal to current node dot next. And that's just going to literally do nothing different. Value equals current node dot next dot value. So then we're going to enter, with this being our value, we're going to say if current node. Ooh, what is this song? Gosh damn. Kanye West? Alright, so this is not going to run. We're just going to go to the next one. And then this is going to run. Start node, which should be 2 now. Yeah, this honestly might work. But what happens when you get to the end? You get to 4. No, you get to 3. And at 3, you say if not current node dot next equals value, which it shouldn't. Current node value should be 3 here. Current node dot next is 4. Start node is going to start node dot next, which should be 3. Current node dot next. Oh my lord, man. Where did I do that at? So current node, that doesn't make sense. Into your heart and let me know. Do things turn black and gray as they go? Alrighty. Closer. And still wrong somehow. Okay. Well, go fuck yourself, honestly. So, current node dot data is 1. Dot data is 2. Value is 1. Start node is 1. Dot next probably. It's probably 5. Caught in a river of ruckus and dreams. Node dot next is equal to none, maybe. Can we do that? Why did that just happen? Why did that just happen? Can I just say none? Why is this happening? Is it that whole reassignment BS again? God, I hate the fucking reassignment BS. All the pointers and God. I'm tired and bound every night, feeling low. My day come back, whatever. What you guys know about this? Tell me what you know about this. Bam. What you know about this? Stuck in the sound, baby. Let's go. Oh, wait. I got this. Fuck yeah. A linked list is said to contain a cycle if any node is visited more than once while traversing the list. Is that even really a linked list, or what is that, bruh? If any node is visited more than once while traversing the list, if you traverse it more than once, you're stuck in a cycle. I mean, I guess that's why it's called that. Well, the thing that I'm considering right now currently is keeping a set of memory addresses. And if I kept a set of memory addresses, then this would work. But worst case scenario, that'll give me a space complexity of O of n. Time complexity, it's negligible. Matter of fact, it's constant time that way. Let me just ask ChatGPT. What we do is we implement a while loop, which is not the first thing. We actually implement a slow equals fast equals head, and we say while fast dot next fast, and we say is fast. Why are you coming fast? Next, next. Slow. And we say fast equals slow. One. Return no. Why are you coming fast? Well, still pretty cool that I saw this problem once and was able to implement the solution from ChatGPT. What is this? Earn 5 points. Are you fucking... Oh, man. Okay. Hop in the whip that you never seen. Find the node where the two lists merge. The merge point is where both lists point to the same node. It is guaranteed that the two head nodes will be different, and neither will be null. Okay, so here we are, I don't know if I read through this. We're given two linked lists and we have to find what element they share, basically. And I will say it's a little bit confusing for me because how can you point to C and X at the same time? You know?
Yeah.
Um, but also, I'm kind of wondering. I'm seeing like an O plus K time complexity solution and a O of N plus M space complexity. Alright guys, so let me pull it up. Where are we at? Okay, so this little challenge of merging these, okay? So I looked through like a bunch of different ways to solve this and I couldn't find anything immediately. So I had to ask ChatGPT for a hint. I asked ChatGPT for a hint and it said 2-pointer. And I really thought about it and I was like, well, I don't see a way of doing this in an N plus M solution. Like, I don't see a way for me to iterate over the input one time. But what I didn't realize was just because a solution is, well, okay, so it only told me it was a 2-pointer, I think, at that point. And then I asked, hey, what's the maximum, or what's the minimum time complexity? And I think it told me N of M. Let me see. Let's see if we can find it. Yeah, N of M is the best time complexity. So I was like, okay, well that basically means that I have to iterate over both sets of input only one time. I'm like, okay, well, um, that doesn't make any sense. I couldn't find a solution there, so then I had to ask it for another hint, and then it told me that, what did it say? It said that I should look at the lengths of the list, and one thing about it is that at the point where it merges, you can guarantee that the rest of the items, you'll basically have the rest of the items in common with the other list. Do I have water around here?
Do you need some?
No, I got it, babe. Thank you, though. So anyhow, with that being said, if you iterate through to the end of the list and just find out how long the two different lists are, then you can line them up in a way that you know that they will, that their merge points will line up, and then you can find the first element that matches on the two of them. So basically, if you were to iterate through one list and you find that one list is length 6 and the other list is length 4, well then you just don't increment, like you don't traverse the second list for 2 iterations and you push the other one 2 iterations forward, since there's a two length difference. So I guess it was not very clear. If one list of length 6 and one length 4, they are off by 2, right? So if you push the one of length 6, if you iterate twice and you get to the 4th element, then both elements, or both lists, now have 4 elements to go, and you can be confident that you will in fact find the merged point in the list, because the merge point from the end going forwards will always be the same length. Like, you can always be sure that the last X elements are the same for both lists, right? I hope that was clear. So, with that said, do we have to iterate through both lists twice? So one thing, the O of N plus M time complexity, that was originally messing me up until I realized that I could iterate over the input basically an infinite amount of times and it would just be a constant. Like, I could, 5M, I could iterate over the input 5 times, and because it's a constant, the time complexity is still N plus M, right? And obviously it would be very nice if we could avoid doing that. And I kind of wonder, at what point is it safe to stop iterating? Like, because I know that if we iterate both lists to the end of their inputs that we're going to figure out what their lengths are, and therefore we can match them up. But is there a way to not iterate over both of the lists twice? Because the first one will help us find the length, and the second one will help us match up the merge points. But what can we do that will help us find how to align them, I think, is the goal. I think the goal is to align them. I don't see a way of doing this where they're not aligned at least within like one, like between -1 and 1 away from each other. With that said, I'm going to probably step back and do a little bit of math and see if I can figure something out. Alright, so I basically failed to solve this problem with an amount of help that I would say makes this me solving the problem. And the solution that ChatGPT says is optimal, which it is far from being the conclusion you would naturally come to if you were just looking at this problem. So a few things I want to talk about is sometimes knowing the time complexity does not help you. Sometimes it's a detriment because when you know that a problem's a certain time complexity, you try to solve the problem in a certain way, and you try to make sure it's as efficient as the time complexity. And I don't know if you guys are anything like me. I tend to see something like O of n plus n and be like, okay, so I iterate through the input once, but that's constant, like, or they remove the constants, right? O of n, they remove the constant times. So realistically, you could iterate through both inputs multiple times. It's just when you simplify it, obviously you get n and m. M and m, that's funny, M and n. Perspective, man. Perspective is so important when solving these problems, and it literally just takes, a very slight notice of, like, just something obscure, or it takes a very slight miss of something, or a tiny miscalculation. Solving a problem like this comes down to a lot of luck and hopefully being in the right headspace, being positioned correctly, working through the question in the right ways. But with that said, we can talk about, we're given two lists where DEF is where they merge, and let's say ABC DEF is the first list, and Z DEF is the second. One way you could solve this is you could say, okay, well, at some point, these two lists are going to, if they are equal to each other, the last element of them will always be the same, right? So if you can find a way to align the last elements to be equal with each other and then compare each value, then you're gold, right? So maybe instead of having this shifted to the left, we have it shifted to the right. So we have Z, D, E, F, and then we have A, B, C, right? Okay, so now you're able to work with this, right? So you could say, well, I know that the length of this list right here is 4, and the length of this one is 6. And you could say, oh, okay, well then if I iterate twice, 1, 2, and then I start comparing both at this point, well, if at any point, these two nodes are equal to each other, they have the same memory address or values or whatever, then you know that you have found a match. And so this right here, this is about as close as you'll get to a natural solution, just working through it in your head. And I did, but I didn't come to this solution. I needed a lot of hints that weren't very helpful, but a lot of hints nonetheless to come to this conclusion. And even when I got to this point, I was like, hey, ChatGPT, is it possible you would have to iterate over both inputs twice? And it told me no, which was a straight lie. So let me show you how ChatGPT would tell you to solve this. So ChatGPT says start with your two things, okay? And what you're going to do is you're going to initialize pointers at the heads of both of these, and then you're going to iterate through both lists, okay? So the first point of significance is here. So we compare. I don't know if we do any comparisons. I don't think we do. I think on the first run you don't compare. No, you don't. I guess another problem with doing it this way is how many comparisons it takes, because you have to compare every value once you once you match the lists up. Whereas here, after a certain amount of iterations, you've actually positively come to the solution. So, I mean, theirs is definitely better, but mine would have worked. And I think working from here to get to this would have been a lot easier. Anyhow, so you get to the end of this list, right? And you're not near the end of this one. At this point, what you're going to do is on the next iteration, you're going to push your pointer from one list to the start of the other, okay? And then you're just going to move your other pointer down to the end, okay? So the next point of significance is you're going to get an arrow at C and you're going to get an arrow at F, okay? So you have 2 pointers on one list. And you're going to flip this pointer over to here now, okay? And you're going to move this one to D. So, how does this work from here? Okay, we're at D. I think I did something wrong. Hold on. No, I don't think I did I? All right, well, let's just step. So, I think I did something wrong. Both start here, get here, D and A, C and F. One here, wait, hold on. One's at A, one's at D. You get C and F. You get D and Z. I think is exactly where we are. D and Z. You get D and E. E and F. F and Z. D and A. E and B. I did something wrong here. How did I do something wrong, though? Bro. I don't understand what I did wrong. Let's see if ChatGPT has a thing that will make more sense. Here and here. We're going to move. We're going to get to this point and this point. We're going to push this pointer to here and this pointer to here. And then we're going to go here and here. And then we're going to 1, 2, 1, 2. Okay, so I don't know why this one worked, but the other one didn't. The merge point to X, and both pointers are pointing to X. And the reason that happened was we started both pointers here. We pushed all the way until one pointer hit the end of the list, right? And then we switched it to the other list. And at that point, we have one pointer at Y, one pointer at A. We put pointer Y to Z, and then it flips. And that's 2 operations. So now we should be at 1, 2. So yeah, I think we should be from A. We should end up at C, I think. Maybe this might have been how I screwed up. Anyhow. Yeah, that is how I screwed up. Somehow, why would I go to B from there? Whatever. Just, if you need more explanation, just go look at ChatGPT or something, or somebody else's video, because clearly I'm struggling to explain this. But literally, you just have 2 pointers, you go until one hits the end of a list, you switch it to the beginning of another list, you go until the other pointer hits the end of a list, and then at some point they meet. So, whatever. We're first going to do the more difficult one. So they do comparisons the entire time, which is interesting. They should start teaching people to count from 0 in schools. Because pointer 1 and 2 does not make as much sense as pointer 0 and 1, but it's just what I go to. Wabam. Saw this one time and got it. And as you can see, the steps I was trying to give you guys are pretty clear here. You literally just iterate one until you hit the end of a list, and then you switch it to the head of the other list, and you just keep pushing it forward otherwise, until they both equal each other. And let's try to implement mine now, which obviously mine's going to be a lot harder to do. Probably actually keep the whole pointer 1 and 2 thing. I don't need to actually, so I won't. Oh. I can't believe I missed this. Holy shit. Yeah, so you can clearly tell that I use quite a bit more code, but time complexity wise, it's really not that much worse. So, just to reiterate over what this does is it keeps track of the length of both of them. It iterates fully through one of the list and then the other, and then it says if it figures out which list is shorter, and then it basically pushes the it moves forward through the nodes until they are equal length, essentially. And then down here it says while they're not equal to each other and neither of them are none, it is going to literally just push both of them forward at the same rate. And then if this condition exits, it should exit with a solution. Since there's always going to be a convergence, it'll return. So, cool. Alright, well that's that. And I'm going to take a short 10-minute break. Alright, back after a short break, and we're on to the next question. Given a reference to the head of a doubly linked list, doubly linked, I think, is back and forth. So it's like an array. How is it doubly linked? Okay, because I can't index it. Okay. And an integer data. Okay. Create a new doubly linked list node, doubly linked list node object, a new node, a doubly linked node, having data value data, and insert it at the proper location to maintain the sort. Am I tripping, or I don't understand where the difficulty is? Whatever. Let's just run it. Less than data. Wait, this is one of those cases where I need to keep the splice of it, so I need to point to this. Doubly linked list node data. Can I pass this? It has. How do you initialize this? What parameters does it take? Okay, Jesus. This has got me lost in the sauce. So, this is going to make the list equal to the node that's supposed to come after this one. this is going to bring us this feels dirty to do. Hopefully this fucking works, man. Well, We're at an hour. How many questions are left?
Come on.
Reverse a doubly linked list. Now that sounds like a bunch of BS that I don't want to deal with. I mean, it's the last one, so I guess I'll do it. Reverse the order of the nodes in place.
Hey, Bladen, where's their collars?
Their callers? Remy's is in the car door. Loba's is in the bathroom.
I'm at leash.
They're either hanging up in the closet or, well, they're either in the closet or they're in the dog coat.
He's so excited he can't sit.
Alright, so reversing a doubly linked list.
Sit down.
From what I can tell, it's going to be a 2-point solution where we start with both pointers at the head of the list, push one to the end, and then after one reaches the end, we swap the elements and then repeat until one pointer is less than the other. Which means that we have to keep track of an index, but I don't know. We have to repeat until we swap.
Sit. Sit, Nova. Sit. Sit. Sit, sit.
So we
sit.
could also keep track, instead of an index, we could keep track of one of the pointers last element they swapped. We could keep the memory address of the last element they swapped, and if the memory address of the element we're comparing is equal to the memory address of the last element we swapped, then we also know that that we're swapping an element we've seen. I mean, we could also keep track of the length of the list. Yeah, I mean, we're going to get the length of the list anyways. We might as well. In an index. At least, yeah, I would say it's probably the way we should go. It's such a small thing anyways. I don't really think it matters. Ugh. Ah! Um...
Come on, Nova. It's your fault. You didn't know potty. It's your fault. What?
Just hearing, yeah.
Remy peed and pooped. Loba didn't do anything.
Yeah, it goes, you know, you figure. What?
The way she was sitting, I was worried she was peeing. Good girl. Good boy. Remy peed and pooped. He's so good. Good boy. I love her so much.
Do one. Pointer 2.
Let's do a good job.
Dot data.
You won't get nothing. Sit. Both. Get back to the hazards. Back off. You hazards. No more. No more. You better back off. That one's Loba's. I mean, you need to learn to eat faster and sound like a pretty princess. You can get your crap stove.
Equal pointer to pointer 1 dot data.
Staring at them, peeking his head out of the tree, staring at him. And then we went to the other side of the tree, so the squirrel was to the other side of the tree, does a sit too. Literally taunting the dogs like,
I think I was going to do that previous. No. Yes. One. Wait. I don't think I'm trying to keep track of like things like previous and next. But now that I think about it, I'm only changing the date. I don't actually change the position of like the nodes and stuff. Do I? Do I? Dude. It does want me to change the position of the nodes. Okay. If it wants me to change the position of the nodes themselves, then I don't need to do anything with the data. Data, you can go bye-bye. You know what? What if I just said, screw this, screw the two-pointer system, Screw list length. I think I don't need that. Bro, my delete key's stuck. Oh no. Oh no. So, what? It gets to the end of the list. Come, let's watch the rain as it's falling down. It's funny because I actually did solve it. It's just not exactly correct. Can I do the same thing backwards? I can do this without going to the end of the list, so I'm gonna go ahead and do that. Ah. Or was I on to something? Okay. So this completes all of the linked list challenges in HackerRank, and I just want to like brush up on what I thought about all of this. So I think linked lists as a data type suck pretty badly. I could see. Actually, I really couldn't see how they're used, but I also haven't really tried. I probably should look into how they're used. Not a huge fan of them. I don't like the fact that they're indexable. I don't like the fact that you have visibility of what's in the list until you iterate through all of it. Until you iterate through it. I don't like that you can't do anything like you can with dictionaries or sets. There's not a lot that I do like about linked lists. Another thing about linked lists is I'm at least glad that I did the challenges, and not because they were fun or entertaining or educate. Well, they're educational is what they were. I think they're the challenges that are in linked lists are things that maybe you don't. They're not obvious like right off the rip. Like when you go to reverse a singly linked list, it's not common sense. You have to do, I think, recursion, if I remember correctly. I want to confirm that after this, but pretty sure you have to do it recursively, right? And then something like what is it? What was the one thing? Oh, finding out where lists merge. There's no way in hell I would have thought about, for one, the thing where you push one faster than the other. What was that? I'm actually gonna go and look at which one that was. Compare two linked lists, merge two sorted, get a node's value, cycle detection. Oh, it was cycle detection is what it was. I never would have thought of like the thing where you push one node twice as fast as the other. And for the finding where they merge, I never would have thought about the two-pointer solution. It's definitely, but it's good to know those things because I feel much more prepared if I do end up getting a linked list problem. I'm kind of curious about the extent of what else there is in the. You might like what else you might find in an interview. Why is my TV unplugged? I wouldn't say any of it was necessarily hard, and I think that the amount of solutions there can be are so limited that it's honestly worth just memorizing them instead of like trying to think through them creatively. I mean, obviously working your creative problem-solving muscles is always nice, but if you're just working for time, I wouldn't really worry about thinking through the solutions. I would just literally just do them. So I'm going to call that good for now. We're going to move on to probably trees next, right? Bye-bye.